Here in the I button and in description box below you will get complete playlist of this chapter. I welcome you to video number 10, and in this video we are going to solve third problem. Okay, third problem on the topic that is Frobenius method. Okay, this question is based on case number 3 that we have discussed in video number 6. Okay, yes, let us start. Before starting this, I would request you to subscribe to my channel if you haven't, and if you learn something from my videos, then please hit the like button and share the playlist as well as this video with your friends. Okay, yes, the question says obtain the series solution of the equation, this equation. Okay, x into 1 minus x y double dash minus 1 plus 3x y dash minus y equals to 0. Let's suppose this is my equation number 1. Okay, yes, here if you put x equal to 0, then you will find that p naught will be 0. Okay, what is p naught? Yes, coefficient of y double dash, that is x into 1 minus x. So on putting x equal to 0, p naught will become 0. Okay, when x equal to 0, p naught will become 0. So we can say x equal to 0 is a singular point. Okay, yes. Then the solution of equation number 1 is given by y equal to summation of n equal to 0 to infinity an into x to the power m plus n. If you expand this, that is, if you put n equal to 0 plus n equals to 1, then n equals to 2, you will get this series. Okay, yes. Similarly, if you differentiate this part with respect to x, you will get this. We have discussed this in video number 7 and 8, where we have solved problem number 1 and 2 on this topic, that is Frobenius method. So I won't be taking much time to find, that is y dash and y double dash. Okay, yes, I believe this is very easy part for you. Fine. Okay, since we have the value of y dash and y double dash, so we will substitute these values in the equation number 1. Okay, yes, so this is going to be, here we have x into 1 minus x. If you open this bracket, you will get x minus x square. Okay, so x minus x square times, from here to here we have y double dash, that is this part. Okay, then we have minus of 1 plus 3x into, yes, from here to here we have this, that is y dash, or you can say dy upon dx. Okay, that is y dash, this part. Similarly, in the last term we have minus y. Okay, so here we have minus of this part is what? Y. Okay, y is this. Fine. So we can say like, we have substituted the values of the values of y dash and y double dash, okay, in equation number 1. So we have this. Now we will try to, yes, we will open this bracket. If you open this bracket, you will see x is multiplied with all these terms. Similarly, minus x square is multiplied with all these terms. Similarly, yes, 1 will be multiplied with all these terms and 3x will be multiplied with all these terms with negative sign. Okay, similarly here you can see negative of this part is equals to 0. Slowly, yes, we will solve each and every part. So first we'll multiply x with all these terms, that is x m into m minus 1 into a naught into x to the power m minus 2 will become x to the power m plus 1. Similarly, if you multiply x with this, you will get, yes, that is m plus 1 into m into a1 into x to the power m minus 1 into x will become x to the power m. Similarly, here you will get m plus 2 into m plus 1 into a2 into x to the power m plus 1. Okay, because of this x, plus dot dot dot. Now we'll multiply minus x square with these terms. So because of this minus, terms will become negative. Okay, negative and dot dot dot. Okay, yes, m into m minus 1 into a naught x to the power m minus 2 into x square will become h to the power m. Similarly, here also negative of, okay, minus of m plus 1 into m into a1 x to the power m plus 1, because x to the power m minus 1 and x square will become what? Yes, that is x to the power m plus 1. Yes, minus of x square into this will give me, yes, this part, x to the power m plus 1. Similarly, if you solve, yes, if you multiply minus x square with this, you will get m with negative sign. Okay, with negative sign, m plus 2 m plus 1 a2, and here it will be m x to the power n plus 2. Fine, yes, minus dot dot dot. So we have solved first term. Now coming to the second term, we are taking this negative common. Okay, yes, now we will multiply 1 with all these terms, then you will see, you will get m into a naught into x to the power m minus 1. This will be as it is. Similarly, this will be as it is. Okay, plus dot dot dot. Now we are multiplying 3x with all these terms. So we'll get 3 in the coefficient of all these terms and multiplying x. Okay, yes, that is, this will become 3 into this part. Okay, that is 3 into m into a naught into x to the power m minus 1 into x. That will become x to the power m. Now coming to the second term. Okay, yes, this part 3x into this, that is 3 into m plus 1 into a naught into x to the power m plus 1. Now coming to this part, that is 3 into m plus 2 into a2 into x to the power m plus 1 into x will become x to the power m plus 2 plus dot dot dot. Now yes, this is as it is, that is minus of a naught into x to the power m plus a1 into x to the power m plus 1 plus a2 into x to the power m plus 2 plus dot 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 equals to 0. Okay, yes. So yes, we have solved up to this part. Now we need to equate, yes, equate the lowest power of x. Okay, lowest power of x to 0. Okay, the coefficient of lowest power of x to 0. And if you see the lowest power of x, what? Yes, that is x to the power m minus 1. So we can say equating the coefficient of lower degree or lower power of x, that is x to the power m minus 1 to 0. You will get, here you can see the coefficient of x to the power m minus 1 is what? M into m minus 1 into a naught. Yes, here we have m into m minus 1 into a naught. Again, if you see the coefficient of x to the power m minus 1, yes, here we have x to the power m minus 1. The coefficient will be in the minus of m into a naught. Minus of m into a naught. Yes, yes, if you search for the coefficient of x to the power m, yes, everything is written here. Okay, yes, and this is equal to 0. Now we are taking common a naught. You will get m square minus m. Here we have minus m, and yes, a naught is taken common already. This will be equal to 0. Since a naught cannot be 0, so we can select this is equal to 0. That is m square minus m. Okay, which is equal to 0. And here we have, yes, m equals to m into m minus 2. If you take m common, you will get m into m minus 2 equal to 0. Okay, yes, this is my initial equation, and on solving this you will get m equals to, okay, yes, what? M equals to 0 and 2. If you solve this part, you will get m equals to 0 and 2. Yes, out of these two values, okay, we will take one as m1 and take other as m2. Okay, if you have seen my video number 6, there I have said when the roots are distinct and differ by an integer. Yes, here the roots are distinct as well as differ by an integer. If you subtract this from this or this from this, we will get an integer always. Okay, here we will always take lower value as m1. Okay, here we will take lower value as m1 and higher value as m2. Okay, so lower value, that is 0, will be taken as m1, and 2, which is a higher value, is taken as m2. Okay, yes, these all things we have discussed in the video number 6. Fine, yes. Okay, now equating the coefficient of x to the power m to 0. Okay, yes, we will search the coefficient of x to the power m in all the terms. That is, yes, here we have x to the power m, so coefficient will be m plus 1 into m into a1. Okay, here we have, okay, yes, here you can see, here we have, okay, yes. Now coming to other terms, yes, that is minus of m into m minus 1 into a naught. Okay, here again you can see minus of m into m minus 1 into a naught. Fine, okay. Again, if you search the coefficient of m x to the power m, yes, here again we have, so minus of m plus 1 into a1, minus of m plus 1 into a1. Okay, yes, minus of m plus 1 into a1. Okay, yes. Now the search is not over yet. Okay, yes, here we have minus of 3 times m into a naught. Okay, so minus of 3 into m into a naught. Yes, again if you search the coefficient of x to the power n, yes, here we have, that is minus of a naught. Okay, yes, so here we can say, yes, minus of a naught equal to 0. Okay, because equated to 0. Fine, yes. Now we will take coefficient of a1 in the left hand side and coefficient of uh, uh, a naught with a naught in the right hand side. Okay, yes, if you solve this part, you will get a relation. Okay, yes, if you solve this part, you will get one relation, that is a1 equals to m plus 1 upon m minus 1 into a naught. Yes, here we will get a1 in terms of a naught. Okay, okay. Similarly, we will equate the coefficient of x to the power m plus 1 to 0. Okay, yes. if you see the coefficient of x to the power m plus 1, that is m plus 2 into m plus 1 into a2. Okay, yes, here we have, yes, this part. Okay, now again let us see, let us search for, yes, here we have, okay, that is x to the power m plus 1, coefficient will be minus of m plus 1 into m into a1. Okay, yes, minus of m plus 1 into m into a1, fine. Okay, now again search for the coefficient of m to the power x to the power m plus 1. Yes, here we have, with negative sign we can write that m plus 2 into a2. Okay, with negative sign, that is m plus 2 into a2. Yes, with negative sign m plus 2 into a2. Yes, again let us search. Here we have, yes, here we have x to the power m plus 1. The coefficient is what? 3 into m plus 1 into a1. 3 into, with negative sign, okay, minus of 3 into m plus 1 into a1, negative sign. Okay, where negative sign comes? Yes, here. Okay, from this, because this all are written inside this bracket. Okay, so minus plus will become negative. Okay, now again search. Yes, here we have x to the power n plus 1 and the coefficient is what? Minus of a1. So we need to write here, that is minus of a1, and that this is equated to 0 finally. Okay, yes, we will write a2 with all the coefficient of a2 in the left hand side, and we'll write a1 with all its coefficient in the right hand side. Okay, yes, again if you solve this part, you will get a2 in terms of a1, that is m plus 2 upon a into a1. Okay, yes, here we have a1 in terms of a0, so put this value, that is you will get a2 in terms of a0. Similarly, yes, you will get a3, a4, a5 in terms of a0. So here we can say a1 equals to m plus 1 upon a minus 1 into a0. Here we can say like a2 equals to m plus 1 into m plus 2 upon m into m minus 1 into a0. Okay, similarly you can find a3, a4, a5 in terms of a0. Fine, let us go ahead. Now since we know that y equals to a0 into x to the power m plus a2 a1 into x to the power m plus 1 plus a2 into x to the power m plus 2 plus dot dot dot. Okay, if you take x to the power m common, you will be left with a0 plus a1 into x to the power 1 plus a2 into x to the power 2 plus dot dot dot. Since we have the value of a1, a2 in terms of a0, we can write here x to the power 1 is as it is, right? Inside this square bracket you need to write this a0 plus a1 is what? a0 into m plus 1 upon m minus 1, write this x here, plus a2 is a0 into m plus 1 into m plus 2 upon m into m minus 1 into, right here, x square plus dot dot dot. Okay, yes, now we can take common, that is a0 we can take common from each terms. Yes, y equals to a0 into x to the power m. Here we are left with 1 only. Here we are left with m plus 1 upon m minus 1 times x plus m plus 1 into m plus 2 upon m into m minus 1 into x square plus dot dot dot, and let's suppose this is my equation number, yes, 2. Okay, now simply, yes, if you see, when we need to find y1, which is my first solution, and for this we need to take, yes, we need to put m equals to 2, which is greater of the two roots. We have two roots, that is m equals to 2 and 0. Greater value is 2. So to find first solution, that is y1, we need to put m equals to 2 in this y. Okay, yes. So this is going to be, if you put m equals to 2 in this equation, you will get y1 equals to a0 into x to the power 2. Here in the square bracket we have 1 plus 1 plus the value of m is how much? 2. So 2 plus 1, that is 3 upon 2 minus 1, that is 1. So here we have 3 into x. Similarly here 2 plus 1, that is 3, 2 plus 2, that is 4 upon 2 into 2 minus 1, that is 2 into x square plus dot dot dot. So this is going to be my y1, which is said to be first solution. Okay, first solution of this equation, where y equals to what? M equals to 2. And what is y? Y this part. Okay, yes. Now if you put, very important thing is coming up. Okay, yes, that is, but if you put m equal to 0 in equation number 2, when you put m equal to 0, okay, in this equation, in this, that is equation number 2, yes, the coefficient becomes infinite. Okay, let us see how it, if you put m equal to 0, this is going to be 1. Okay, there is no problem in this case. Yes, here, because of this m only, if you put m equal to 0, so the coefficient of m square will become what? Infinite. So we need to overcome this difficulty. Okay, yes, to overcome this difficulty we need to put b a naught equals to b naught into m minus m1. Okay, to overcome this difficulty, we will put a naught equals to b naught into m minus m1, and the value of m1 is what? 0. Okay, yes, m1 equal to 0 and m2 equals to 2. Okay, yes, so b naught into m minus 0 will become b naught into m, and we need to put, yes, b naught into m in place of a naught. So yes, yeah, we need to see this equation. In place of a naught, we need to write b naught into m. Okay, and we will multiply m in all the terms. So this is going to y equals to b naught into m. M is multiplied in all the terms. Fine, yes. So here we will get b naught into x to power m, m plus m into m plus 1 upon m minus 1 into x. Here we have m will get cancelled, so we are left with m plus 2 into m plus 1 upon m minus 1 x square plus dot dot dot. Okay, yes. Now we will differentiate, yes, partially with respect to m. Okay, yes, we will partially differentiate with respect to m, this y. Okay, so del y upon del m is going to be, yes, here we have u into v form. Okay, since we are differentiating with respect to m is present in this function as well as here also. Okay, so here we have basically u into v form. Fine, first we will differentiate this taking this as constant, then we will differentiate this taking this as constant. Okay, b naught is a constant value, so let it be. So if you differentiate this part taking this as constant, so we need to write b naught into differentiation of this part. Okay, that is x to power m into log x. If you have gone through video number 8, I have discussed this in brief. Okay, yes, I'm not taking much of time in discussion in discussing this part, because we have already discussed about this in video number 8. Okay, where we have solved problem number 2. Okay, when the roots were repeated. Okay, yes. So here we have b naught into x to differentiation of x to power m will become x to power m into log x, and this part will be as it is. Fine. Now we'll taking this as constant, we'll differentiate this part. Okay, that is b naught into x to power m. Okay, differentiation of this part will be 1 with respect to m. Now here we need to use u upon v form of differentiation. Okay, before that we need to open this bracket, so numerator will be m square plus m, and in the numerator part we have m minus 1. Okay, if you apply differentiation of division rule of differentiation, you will get, on solving this part, you will get m square minus 2m minus 1 upon m minus 1 whole square. Okay, write this x here. Similarly, if you solve this part, you will get m square minus m minus 5 upon m minus 1 whole square into x square plus dot dot dot. Okay, so here we have del y upon del m. Now we need to find the second solution. For that we need to put m equal to 0. Okay, for that we need to put m equal to 0 in this, that is y2 equals to del y upon del m, when m equal to 0 is equals to, yes, if you put m equal to 0 here, this will become 1. Okay, so b naught into log x, b naught into log x, if you put here, okay, 0, this will become 0. Now put x equals to, sorry, m equals to 0. Okay, m equal to 0, this is going to be 0. Okay, yes, this is since m is multiplied with this, so this is going to be 0. Now coming to this third term, that is 0 plus 2, that is 2, 0 plus 1, that is 1, upon 0 minus 1, that is minus 1. Because of this minus 1 only, I have write this negative sign, and x square will be as it is, minus dot dot dot. Now coming to the second term, okay, that is b naught into x to power m will become b naught, this will become 1. Here we need to put m equal to 0, so this is 1, there is no change. 0 minus 1. Okay, upon minus 1 whole square will become 1. So this is going to be minus 1. Okay, minus 1 into x. Similarly, if you solve this part, this is 0, 0, minus 5. Minus 5 upon 0 minus 1. That is minus 1 whole square will become again 1. So this is going to be minus 5 into x square plus dot dot dot. Okay, yes. So if you solve this part, you will get b into log x. This is minus of 2 square minus dot dot dot. If you solve this part, that is b naught into 1 minus x minus 5x square minus dot dot dot. So similarly, yes, since we have the value of y2 and y1, okay, yes, here we have the value of our y1. Okay, so we can write the complete solution, that is, yes, here. Hence the complete solution is given by y equals to c1 into y1 plus c2 into y2. What is y1? Y when m equals to 2. Okay, so c2 into y when m equals to 2 plus c2 into what is y2? Del y upon del m when m equals to 0. Fine. Yes, we need to write c1 here. Y when m equals to 2 is what? This part. Okay, this part is what? Y when m equals to 2. Okay, yes, plus c2 into del y upon del m when m equal to 0, which is this. Okay, yes, so we need to write this. Before writing this, we need to take b naught common. So c2 into b naught, here we are left with log x minus 2x square minus dot dot dot. Here we are left with plus of, this is minus 1 minus x minus 5x square minus dot dot dot. Okay, and this is what? This is my required solution. Okay, this is my required solution. Okay, thank you so much for watching this video. Thank you.